Good morning, students. In the last class, we learned about scalar triple product. And in today's class, we are going to discuss about vector triple product. Question number 10 in exercise 6.2. Three non-zero vectors are there, A vector, B vector and C vector, such that C vector is a unit vector that is perpendicular to both A vector and B vector. If the angle between A vector and B vector is pi by 6, show that the square of the box product of A vector, B vector, C vector is equal to 1 by 4 into modulus of A vector square, modulus of B vector square. So listen, it is given C vector is a unit vector that is perpendicular to both A vector and B vector. So listen, the direction of A vector cross B vector and A vector comma B vector are perpendicular. So since C vector is perpendicular to these two vectors, C vector will be parallel to the direction of A vector cross B vector. Okay. So we have C vector is parallel to A vector cross B vector. Now you can take the box product of A vector, B vector, C vector. That is equal to, you can write it as A vector cross B vector dot C vector, scalar triple product. Okay. That is equal to, now we are using the formula A vector dot B vector. A vector dot B vector, the formula is modulus of A vector, modulus of B vector cos theta. So here we have modulus of A vector cross B vector into modulus of C vector, then cos theta. So listen here. So I am taking two vectors. This diagram you don't want to draw for the test. So what we have here, C vector is parallel to A vector cross B vector. Okay. So one you can take it as C vector and another one you can take it as A vector cross B vector. So if both are parallel means then the angle between them will be 0. So here the angle is 0. And sometimes they both will be parallel but they may have opposite direction. Suppose for one vector it is in this direction, the other vector in this direction means the angle formed there will be 180 degree. Okay. So cos instead of theta you have to take phi. So two angles will get it, maybe cos pi or cos 0. So it is equal to cos pi means the value is minus 1, cos 0 means it is 1. So you can write it as plus or minus. Okay. So plus or minus modulus of A vector cross B vector into modulus of C vector you'll get. Then instead of modulus of A vector cross B vector, you can use the formula. Modulus of A vector, modulus of B vector, sine theta, sine of the angle between them. And listen, n cap we will get, isn't it? Here we are taking modulus. Modulus means modulus of n cap, it will become 1. Modulus of a unit vector is 1. So that n cap we did not write here. Into this modulus of C vector. So it is equal to 1 by 2 into, that is sine 30, the value is 1 by 2. In the question it is given the angle between A vector and B vector is pi by 6. So in sine theta, instead of theta we are writing pi by 6 here. So plus or minus 1 by 2 into modulus of A vector, modulus of B vector. In the question it is given C vector is a unit vector. So unit vector means the modulus of that is equal to what? 1, isn't it? So that will become 1. So you can remove it. Now we can square it on both the sides. When we square it, you'll get box product of A vector, B vector, C vector square equal to, here when you square this plus or minus will go, isn't it? That is 1 by 4 into modulus of A vector square into modulus of B vector square. Example 6.17. If the vectors A vector, B vector, C vector are coplanar, then prove that the vectors A vector plus B vector, B vector plus C vector plus A vector are also coplanar. So solution, it is given the three vectors are coplanar. So you can write box product of that is equal to 0. Now you have to say these three vectors are coplanar. So we have to prove that the box product of these three vectors are equal to 0. So it is equal to, we are going to apply the property here. So you fix the, that is you see the first term. I am going to, here we have sum of two vectors. Here also we have in the same way only. Now I am seeing only the first term. So I can write it as sum of two box product, isn't it? So A vector, then this second term, third term will be same. Then plus B vector, these two terms will be same. Okay, like this you'll get. Now I am going to see the second term. This I am going to write it as sum of two box product. So A vector, B vector, this same, C vector plus A vector. Then A vector plus A vector. Same way I can write this also as sum of two box product. See the second term. So b vector, c vector plus a vector plus c vector, that is b vector, c vector plus a vector. Now this you can write it as sum of two vector, that is two box product. This also you can write it as sum of two box product, like that. When you write each and every term, you will get 8 box product totally. This you write in the same way. And in a box product, if two vectors are same, means that value will become 0. So this will become 0, this will become 0, this also 0. So like that it will be going on. Last term you will get, okay. And you see here we have b vector, c vector, a vector. And this you can write it in cyclic order, no? That is, we can start with a vector. So a vector, b vector, c vector you can write. So 2 times you have box product of a vector. This is vector, okay. A vector, b vector, c vector. So it is equal to 0 because we have here its value is 0. So here also it will become 0. So you can say a vector plus b vector plus c vector plus a vector are coplanar. Before we saw scalar triple product, now we are going to see vector triple product. So here also 3 vectors will take the product of 3 vectors, but its product will become a vector value, okay. For a given set of 3 vectors, a vector, b vector, c vector, the vector a vector cross b vector cross c vector is called a vector triple product. Note, that is a vector triple product you can write in any one of these forms, okay. You can interchange the bracket. Theorem 6.7. The vector triple product satisfies the following properties. First one, a1 vector plus a2 vector cross b vector cross c vector is equal to a1 vector cross b vector cross c vector plus a2 vector cross b vector cross c vector. Okay, like this you can write. Then lambda a vector cross b vector cross c vector is equal to, if a scalar is there, that you can take it outside, lambda into a vector cross b vector cross c vector. Second point, a vector cross b1 vector plus b2 vector cross c vector is equal to a vector cross b1 vector cross c vector. Then plus a vector cross b2 vector cross c vector. Okay, otherwise like this you remember, first you will get b1 vector cross c vector, okay, plus b2 vector cross c vector. Along with this you are taking this a vector. Now a vector cross lambda b vector cross c vector. Here also same way, if we have lambda in the second place also, you can take it outside. Then a vector cross b vector cross c1 vector plus c2 vector is equal to, this also same way, how you can remember, b vector cross c1 vector you will get. Along with this a vector you are taking. So a vector cross b vector cross c1 vector, then plus a vector cross b vector cross c2 vector. Now a vector cross b vector cross lambda c vector equal to, lambda you can take it outside where lambda is a real number. Remark, vector triple product is not associative. That is, when we interchange the bracket, the value will not be same. And for this, they have given one example why it is not equal. You take like this, a vector as I cap, b vector as I cap, c vector as j cap. So it is, now I am finding the left hand side, a vector cross b vector cross c vector. It is equal to, listen here, I am replacing the value I vector cross I cap cross j cap. It is equal to, I am writing this I cap in the same way. Here I have I cap cross j cap. You can put determinant also and you can simplify. Otherwise, how you can remember is, you see here, always you have to take in a anti-clockwise direction, and in cyclic order it will come. Cyclic order means I cap, j cap, k cap, like this you take. Okay, you take it, and I cap cross j cap, it will be equal to k cap. J cap cross k cap, it will be equal to I cap. K cap cross I cap is equal to j cap, which is not there, you will get. Okay, but if you take in opposite direction, in clockwise direction when you take means, same way only it will come, but one minus sign you have to put there. So you see here, this I cap I am writing in the same way, cross I cap cross j cap. So I cap cross j cap, it is equal to what? K cap we'll get. So I cap cross k cap now. It is equal to I cap cross k cap means it is coming in opposite direction. In this direction it is coming. So it will be what? Minus j cap. Okay. Now this is the left hand side value. I am finding the right hand side value. In the right hand side value, I cap cross I cap means its value is 0. The cross product of same vector means it will become 0. So 0 cross j cap is 0 vector only. So now you see both the sides are not equal. Theorem 6.8. For any three vectors A vector, B vector, C vector, we have A vector cross B vector cross C vector equal to A vector dot C vector into B vector minus A vector dot B vector into C vector. So this is a formula. How we have to remember is along with the first term you take the last term. So A vector dot C vector into the middle term B vector. Okay, here don't put a dot, it is ordinary multiplication. Then minus, you have to take in the same order, that is A vector dot B vector into C vector. So proof, first we are going to choose the coordinate axis as follows. So x-axis is chosen along the line of action of A vector. Y-axis is chosen in the plane passing through A vector and parallel to B vector. And z-axis is chosen perpendicular to the plane containing A vector and B vector. Okay. So in short, how we can remember is A vector is on x-axis. Then B vector is in the xy plane. Okay. And C vector is in the xyz plane. So how we can take this A vector? A1 I cap. Only x-axis we have to take up. B vector in the xy plane. So B1 I cap plus B2 j cap. C vector in the xyz plane. So C1 I cap plus C2 j cap plus C3 k cap. So now we can take the left hand side. A vector cross B vector cross C vector is equal to, instead of A vector you can write A1 I cap, then cross B vector cross C vector. The cross product of two vectors means it is determinant. In the first row you have to put I cap, j cap, k cap. In the second row take the coefficients of B vector. It is B1, B2 and 0. Here you see B1, B2 and 0. Then C vector, take the coefficients of C vector. It is C1, C2, C3. Now you can expand this. That is A1 I cap we have outside cross. I cap into leave the first row and first column. So you will get B2, C3 into I cap. Minus j cap into, leave the first row and second column, you will get B1, C3. Then plus k cap into, leave the first row and last column, it is B1, C2 minus B2, C1. Now it is equal to, now we have to take the cross product of this A1 I cap and these two terms. So A1 I cap cross B2, C3 I cap. So I cap cross I cap means its value is 0 vector. Okay. The cross product of two same vector is 0 vector. So that term you can remove. Then when you take cross product of this first term and this term means here first you multiply the coefficients. What we have? Minus A1, B1, C3. So write it first. Then we have I vector cross j cap. That is I cap cross j cap. It is equal to what? K cap. Okay. So that you can write. Then along with this term, you take this last term. So here also A1 into this term I am writing in the same way. You will have I cap cross K cap. Okay, I cap cross K cap means you just think how you have to write. I said you have to write it in a cyclic order. I to J, J to K, K to I. So K to I we should get. But here we have I to K, isn't it? I cap cross K cap. So you have to write minus j cap. Actually one minus will come. If you take that minus inside only, this term will become plus. This is minus. Now you can take the right hand side. It is A vector dot C vector into B vector minus A vector dot B vector into C vector. It is equal to A vector dot C vector means we have to find the dot product of these two terms. Take the coefficients of I cap and multiply it. A1 into C1. So that only I have written. This no symbol is this. Okay. So into like this you can write just ordinary multiplication this into B vector term. B vector is B1 I cap plus B2 j cap. Then here what we have minus a vector dot b vector is there, isn't it? So a vector dot b vector means find the dot product of these two terms. Multiply the coefficients of I cap. A1, B1 we have. Okay, so here you have A1, B1. Then if you take a J cap means here there is no J cap. So 0 into B2 it will become 0. So you don't want to take that. Into C vector. C vector you write. Okay. Now it is here when you take this A1, C1 inside, it is A1, C1, B1 I cap. And here also you'll get the same term but minus of that. Minus A1, B1, C1 I cap. So that first terms you can cancel. Now I am going to take this A1, C1 to the second term. So here we have J cap. Here also one J cap term is there. Okay. So from both the terms A1 you can take outside. If I take A1 outside, C1, B2. Okay. J cap also I am taking outside. Here what you'll get minus B1, C2. Okay. So like this you'll get for J cap. Then K cap term. Only one K cap term is there, isn't it? So take this minus A1, B1 inside. It is minus A1, B1, C3 into K cap. So now from equation 1 and 2, that is this is our equation 1 and this is equation 2. So from equation 1 and 2 we get A vector cross B vector cross C vector is equal to A vector dot C vector into B vector minus A vector dot B vector into C vector. Jacobi's identity and Lagrange's identity. Theorem 6.9. For any three vectors A vector, B vector, C vector, we have A vector cross B vector cross C vector plus B vector cross C vector cross A vector plus C vector cross A vector plus A vector cross B vector equal to 0 vector. So this how we are going to prove is you take the first condition, that is A vector cross B vector cross C vector, it is equal to, we are going to use that is vector triple product formula. Along with the first term you take the last term dot product of that, that is A vector dot C vector into this B vector minus, in the same order we are going to take A vector dot B vector into C vector. Same way, if I take the next term, what you'll get along with the first term, take the last term. B vector dot C vector, B vector dot A vector into C vector minus B vector dot C vector into A vector. For the third term also I am going to do the same. So it is C vector dot B vector into A vector minus C vector dot A vector into B vector. Now you can add all the terms. In the left hand side when you add you will get this. Okay. In the right hand side when you add you can cancel all the terms. That is A vector dot B vector into C vector. It is same as B vector dot A vector into C vector. These two terms you can cancel. Then B dot C into A vector is same as C dot B into A vector. And this first term and this last term you can cancel. Okay. So you will get 0 vector in the right hand side. This only you want to prove. Theorem 6.10. Lagrange's identity. For any four vectors A vector, B vector, C vector, D vector, we have A vector cross B vector dot C vector cross D vector is equal to determinant of A vector dot C vector, A vector dot D vector, B vector dot C vector, B vector dot D vector. This is also a formula only. It is a dot product of four vectors. It is equal to, how you have to write this, you have to put a determinant. Along with the first term, you take these two terms. That is A vector dot C vector, then A vector dot D vector. First row term you will get. Then with the B vector, you take these two terms. B vector dot C vector, B vector dot D vector. Second row terms you will get. So since dot and cross product can be interchanged in a scalar product, we get, that is I am taking the left hand side first, and before in one property we have learned that the dot product, dot and cross can be interchanged. When we interchange we have to change the bracket also. So I am taking this dot inside, that is here, dot here, and this cross here. Then I have to put a bracket for cross product. Okay, so this A vector dot, then I have to put a bracket B vector cross C vector cross D vector. So it is equal to A vector dot. Now it is of the form cross product of three vectors. Okay, so vector triple product form. So how you have to write B vector dot D vector into C vector minus B vector dot C vector into D vector. So like this we will get. It is equal to, now we can write like this. This A vector dot you have to take for both the terms. So it is A vector dot C vector into ordinary multiplication. Okay. A vector dot this C vector. A vector dot C vector into B vector dot D vector. Same way this A vector dot I am taking along with D vector. So minus A vector dot D vector into B vector dot C vector. Okay, it is like multiplication. Multiplication means we'll multiply with only one term, no? Like that you have to take. Now this is nothing but our answer. Determinant of A vector dot C vector, A vector dot D vector. Then B vector dot D vector, B vector dot C vector. Okay, if you multiply it and see, you'll get the answer. A vector dot C vector into B dot D minus A dot D into B dot C. Okay, so you'll get the answer. Exercise 6.3, question number 1. If A vector equal to I cap minus 2j cap plus 3k cap, B vector equal to 2i cap plus j cap minus 2k cap, C vector equal to 3i cap plus 2j cap plus k cap, find first subdivision A vector cross B vector cross C vector, second subdivision A vector cross B vector cross C vector. So first I wrote all the given vectors. So we have to find out A vector cross B vector cross C vector. So first I am finding the term what is given inside the bracket. A vector cross B vector is equal to determinant of, in the first row you take I cap, j cap, k cap. Then the coefficients of A vector. It is 1, minus 2, 3. Then coefficient of B vector. 2, 1, minus 2. Okay. So you know how to expand it. Isn't it? Plus, minus, plus and you expand it. You'll get the answer like this. I cap plus A j cap plus 5 k cap. Now we can find A vector cross B vector cross C vector. So determinant of, it is like a cross product of two vectors. That is, take this is one vector and this is the next vector. So I cap, j cap, k cap. Then take the coefficients of A vector cross B vector. It is 1, 8, 5. Then take the coefficient of C vector. It is 3, 2, 1. So when you expand this, what you'll get? I cap into 8 minus 10. Then minus j cap into 1 minus 15 plus k cap into 2 minus 24. It is minus 2 I cap. Here plus, it will become plus, minus into minus plus. So 14 j cap minus 22 k cap. Now second subdivision. We have to find out A vector cross B vector cross C vector. So first we can find B vector cross C vector. It is equal to determinant of I cap, j cap, k cap. Take the coefficients of B vector. 2, 1, minus 2. Then coefficient of C vector. 3, 2, 1. So when you expand it, you'll get the answer like this. 5 I cap minus A j cap plus k cap. Then A vector cross B vector cross C vector. It is equal to determinant of I cap, j cap, k cap. The coefficients of A vector. The coefficients of B vector cross C vector. So you'll get 22 I cap plus 14 j cap plus 2 k cap. Question number 2. For any vector A vector, prove that I cap cross A vector cross I cap plus j cap cross A vector cross j cap plus k cap cross A vector cross k cap equal to 2A vector. So first we have to write the formula. A vector cross B vector cross C vector is equal to, take the dot product of first and last term. It is A vector dot C vector into B vector minus A vector dot B vector into C vector. It is given in the question. A vector is any vector. Okay, so I am taking like this. Let A vector equal to A1 I cap plus A2 j cap plus A3 k cap. Now you can consider the first term. I cap cross A vector cross I cap. It is equal to, you can use the formula I cap dot I cap into A vector minus I cap dot A vector into I cap. So I cap dot I cap is what? 1. Multiply the coefficients. 1 into 1 is 1. So 1 into A vector. Okay, so it is A vector. Then minus I cap dot, take the value of A vector. It is A1 I cap plus A2 j cap plus A3 k cap into this I cap. So in the next line what you'll get is, when we take the dot product of these two, Multiply the corresponding terms. 1 into a1, it is a1. Other terms, it will become 0. Isn't it? Here there is no j cap term and k cap term. So it will become 0. When we find the dot product of these two, only a1 will be there. So a1 into I cap. So in the next step, what you'll get is a vector minus a1 I cap. So listen, the value of I cap cross a vector cross I cap is a vector minus a2 I cap. Mark it as equation 1. Similarly, we can write the value of other two terms. Okay. So how you have to write is a vector minus, instead of a1, we have to write a2. In a cyclic order, you have to write, instead of a1, you write a2. Instead of I cap, you write j cap. Okay. Mark it as equation 2. Then when you take the next term, it is equal to a vector minus, instead of a2 you have to write a3 into k cap. Mark it as equation 3. So add all the three equations. When you add all the three equations, here what you'll get, a vector plus a vector plus a vector. It is 3a vector. Okay. So 3a vector, then minus, for these three terms we have minus, you can take that minus outside. It is a1 I cap plus a2 j cap plus a3 k cap. So this we took it as a vector at first, no? So instead of this, you can replace a vector. 3a vector minus a vector is 2a vector. Question number 4. If a vector equal to 2i cap plus 3j cap minus k cap, b vector equal to 3i cap plus 5j cap plus 2k cap, c vector equal to minus I cap minus 2j cap plus 3k cap. Verify that these two subdivisions we have to check. A vector cross b vector cross c vector equal to a vector dot c vector into b vector minus b vector dot c vector into a vector. Same way, a vector cross b vector cross c vector is equal to a vector dot c vector into b vector minus a vector dot b vector into c vector. We can find a vector cross b vector first. It is determinant of I cap, j cap, k cap. Then we'll write the coefficients of a vector and b vector. Expand it, you'll get the answer as 11 I cap minus 7 j cap plus k cap. Now you can find a vector cross b vector cross c vector. Okay, so it is equal to same way, determinant of I cap, j cap, k cap. Then take the coefficients of a vector cross b vector. In the last row, you take the coefficients of c vector. When you expand it, you'll get minus 19 I cap, minus 34 j cap, minus 29 k cap. Mark it as equation 1. Now you can find the right hand side, that is a vector dot c vector. Write the value of a vector dot, write the value of c vector. So how we have to find the dot product, multiply the coefficients. So 2 into minus 1, then plus 3 into minus 2, minus 1 into 3. So it is minus 2, minus 6, minus 3. That is equal to minus 11. Now a vector dot c vector into b vector is equal to, the value of a vector dot c vector is 11 into b vector, it is given in the question. You can take this minus 11 inside, minus 33 I cap, minus 55 j cap, minus 22 k cap. This is equation 2. Now you can find b vector dot c vector. So this is b vector value dot c vector value. So multiply the corresponding coefficients. So 3 into minus 1, it is minus 3. 5 into minus 2, it is minus 10. 2 into 3, it is 6. So it is 6 minus 13, so minus 7. Now you can find b vector dot c vector into a vector. It is equal to b vector dot c vector equal to minus 7 into a vector is 2 I cap plus 3 j cap minus k cap. Take this minus 7 inside. It is minus 14 I cap minus 21 j cap plus 7 k cap. Mark it as equation 3. Now equation 2 minus equation 3 implies, okay, in the left hand side you'll get like this and in the right hand side you'll get the terms like this. So you can subtract the corresponding coefficients, minus 33 plus 14. Okay, so it is minus 19. Then minus 55 plus 21. It is minus 34 j cap. Then minus 22 minus 7. It is minus 29 k cap. Mark it as equation 4. From equation 1 and 4 we get A vector cross B vector cross C vector is equal to A vector dot C vector into B vector minus B vector dot C vector into A vector. Now second subdivision, you have to prove A vector cross B vector cross C vector equal to A vector dot C vector into B vector minus A vector dot B vector into C vector. So we are going to find the left hand side first, and here what is given inside the bracket I am finding. B vector cross C vector. So you know how to calculate, isn't it? So the answer will be 19 I cap minus 11 j cap minus k cap. So A vector cross B vector cross C vector is equal to I cap, determinant of I cap, j cap, k cap, coefficient of A vector, coefficient of B vector cross C vector. So when you expand, you are getting like this, minus 14 I cap, minus 17 j cap, minus 79 k cap. This is equation 1. Now we are going to find the right hand side value. A vector dot C vector into B vector. This value we have found out already. This is equation 2. A vector dot B vector equal to, this is our A vector value, this is B vector value. So the dot product of these two vectors, multiply the coefficients, 2 into 3, 6, 3 into 5, 15, minus 1 into 2, minus 2. So you'll get 19. So A vector minus B vector, A vector dot B vector into C vector is equal to 19 into C vector value. So this 19 you can take it inside, minus 19 I cap minus 38 j cap plus 57 k cap. Mark it as equation 3. Equation 2 minus equation 3 implies, okay, in the left hand side you'll get like this, in the right hand side we have the terms like this. So minus 33 plus 19, it is minus 14 I cap. Then minus 55 plus 38, it is minus 17 j cap. Minus 22 minus 57 minus 79 k cap. This you mark it as equation 4. So from equation 1 and 4 we get A vector cross B vector cross C vector is equal to A vector dot C vector into B vector minus A vector dot B vector into C vector. Max homework. Example 6.16, 6.18, 6.22. In exercise 6.3, fourth one, second subdivision and fifth sum. Thank you, students.